In this limit here, it appears that we can use infinitesimals, right, and substitute this tangent x squared by just x squared. But it's dangerous to do that because I warn you to do this when you have these expressions involved in a sum or a difference, simply because in the differences there can be cancellations of small terms, and it can spoil you the result, right? And in this case, this term there's a sum, but this term can be positive or negative because it's around zero. So actually, there is a hidden difference in here. But anyway, we don't have to do that because we can factor out here the x in the denominator, right? And rewrite the limit as this. It's the tangent of x squared plus 2x divided by x times 1 plus x, okay? And then we can, there is a product here, so we can multiply or split the limit as the limit of 1 over 1 plus x times the limit of the rest, tangent x squared plus 2x divided by x, okay? It's the limit of a product, so we calculate this as the product of limits. And of course, this limit is just 1, right? So we just have to calculate this limit here. But this limit splits also into two limits, right? First is the limit of the first fraction, which is the tangent of x squared divided by x. And second, you have the limit of the second fraction, which is 2x divided by x, right? And since the x cancels, this limit is just 2, right? So you have 2 plus, and then you have this limit here. But now you can, you are entitled to use infinitesimals because now this is involved in a product, in a quotient, right? So you can just replace the tangent of x squared by x squared when x goes to 0, because when x goes to 0, x squared goes to 0 as well. So if you do that, this is just the limit when x goes to 0 of x squared divided by x, which, canceling one factor x, all right, gives you just x. So this limit here is 0, and the limit we're talking about is just 2.